Okay, so we're still on lesson 1.2. Whoops, isn't it fun when you move the P? We're still on lesson 1.2, but we're on part 3. And what we're going to be concentrating on today is word problems or word situations. And I know you're thinking, oh my gosh, these are so difficult. They're not. They're just words. So you're all fine. Okay, so the first problem we're going to be doing, I would recommend that you put your work right over here. Okay, and you can flow down into this. That won't be a problem at all. Okay, or if you find some other room, I'll let you decide that. So the first problem we're looking at today is going to be what's called consecutive integers. So it's talking about the sum, which is an important part. We need to pay attention to that. The sum of 3 consecutive integers. So let's first concentrate on integers and consecutive. We know that from lesson 1, integers are positive and negative whole numbers. To be consecutive, well, let's look at that. Let's take an example. If I have a number, let's say 11, and I want 3 consecutive. If 11 is my first integer, what would be my second integer? Right, 12. Because consecutive just means one right after the other. So if 12 is my second one, what is my third one? 13. Now I just arbitrarily pick numbers here, okay? And we're just going to now look at if we're doing it in general. We go back to that thing with the variables. So we're going to start off by saying, what if x is our first consecutive integer? Okay, if x is our first consecutive, then we want our second consecutive. Well, what we can do is we can look at what we know and what our example, what I used. What do I do to 11 to get to 12? I add 1, exactly. So I'm going to add 1. Now we need our third consecutive. Okay, now here's the weird part. You would think that we'd just go, oh, 12, what do I do to 12? No, because my first one is x, I have to base my third one off of that also. So what do I do to 11 to get 13? I add 2, exactly. And so now what we're doing is we're going to take the first consecutive plus the second consecutive plus the third consecutive to get our sum. Okay, so what's our first consecutive? That's right, it's x. What is our second consecutive? X plus 1. Now for emphasis sake, I'm going to put it in parentheses so you can see where I'm doing. We don't need those parentheses, but those are just kind of helpful to see. And then I'm going to give my third one, which would be x plus 2. And what's my sum? 132. Now when we go to solve it, those parentheses are just dividing it. So all we're going to do in order to solve it is we're just going to combine like terms. So if I combine my like terms, I get 3x. Combine my like terms, and I get 3. Is equal to 132. Now we're just going to solve this equation. And hopefully this is not anything that is a big deal for you. You're going to subtract 3. You're going to get 3x is equal to 129. Divide by 3. And we get 43. So that's our first consecutive integer. Okay? So now we come over here and we're going to answer this. And if 43 is our first consecutive answer, well, we could take and plug in and would go 43 plus 1 is equal to, or we could just go, well, 43 is our first, isn't 44 our second? And then after that is 45. So this is our answer. Okay? Now the next problem we're going to be talking about, and what's very common, is we have what's called consecutive odd numbers. And we have consecutive even numbers. Let's look at even first. Okay, so let's look at even. If I have an even number, pick an even number. We'll say 14. What's the next consecutive even? 16. And the next, 18. So going back to what we talked about is that if my first one is x, consecutive even, then x plus, well, what do I do to 14 to get to 15? I add 2. And what do I do from 14 to get to 18? I add 4. Okay? So that's consecutive even. Consecutive odd, well, let's take an odd number. Let's say that we have 21. What is the next odd number? 23. And the next one, 25. And this is where it's kind of weird, because if we look at it, okay, consecutive even, it's like, oh yeah, add 2. But that's the interesting thing about it. If I'm on consecutive odd, what do I do to the first one to get to the second one? I add 2 still. So even and odd are going to look the same. So this is going to be true for even or odd. It's going to be exact same. I'm always going to add 2. Okay, but notice what I did here is that you can always go back and find a number. Plug a number in and figure out what it's going to be. So this technique that I'm showing over here, okay, on this part over here, is that I'm just showing you if you get stuck on something, plug in real numbers and then go back and see what you did. Okay, so let's go back to yours. In your workbook, you have this problem, and so we're going to do this one. And notice again, we're going to do a sum, and we're looking at 3 consecutive odd integers. So the first thing we're going to do is we're going to describe those. So if x is our first one, okay, and we need our second consecutive, what did I do to get from the first one? So think back to that 21. I had to add 2. And then we have our third. And we're just going to use ditto marks. Hope you're familiar with that when you're taking notes. This just means it's the exact same word, but it's down here. And that's going to be x plus 4. So now we're going to go first plus second, but we have to plus third is going to give us our sum. So we have our first consecutive integer, which is x, our second consecutive integer, which is x plus 2, our third consecutive integer, which is x plus 4, is equal to our total of 57. And of course, we start off by combining like terms, x plus x plus x. And our like terms are 2 and 4, so we have 6. And now we have an equation we're going to solve. So go solve that. So we find out that x is equal to 17. That, of course, is not our answer. We're not done yet. And if you did not get 17, go back and look over your work and see if you can find it and compare your work to mine. So if the first number is 17, then the second number is 19, and then 21. So those are our 3 consecutive integers. Now you can always check your work by going 17 plus 19 plus 21, adding that up, and you're going to get 57. Okay? We're just going to continue on in your workbook to the next problem. And these are what are called mixture problems. And they're really confusing at first. So we're going to pick apart what's there. And then we're going to use what I call a word equation to then figure out, to symbolize it. And then we're going to plug in what we know. So if the lab technician needs 30 liters, you know that that's going to probably be important somehow. So we want to pay attention to 30 liters of 25% acid solution. How many liters? Okay, so that's what we're looking for, is how many liters of the 10% and the 30% should she mix to get what she needs. So what's happening here is that she needs 25% acid solution. Okay, and we're going to mix a 10% plus a 30% in order to get that. Okay, so we're going to mix these two solutions in order to get a 25. So all I'm doing is I'm kind of just clarifying what's my project, what is my situation, and I'm going to go from there. So now what we need to understand is that she's going to be mixing the 10% and the 30%. Well, how much do I end up with? Well, I end up with 30 liters. So that's going to make a difference. Okay, so if I have 30 liters at the very end, that means that I'm going to start off by saying I have X is the number of liters of the 10% and the 30% should she mix to get the total. And this is where you have to decide. Okay, so X is liters. That's the how many of each do I need to have. And what we're going to do is we're going to choose one of them to be the variable, either the 10% or the 30%. Okay, and I'm just going to choose we need X number of liters for 10%. Okay, now if that's what we need for 10%, what do I need for the 30% in liters? Well, here's what you need to understand. Let's pretend for a second that for the 10% we need 5 liters. Well, if I have to have a total of 30 liters, what does that mean I have left over? 25 liters, exactly, because I took 30 minus what I said that I had. Okay, now I'm saying that I have X number of liters. So for what that means for the 30%, I have the total, I'm sorry about the numbers, this 30% has nothing to do with the 30%. But what I'm going to do is I'm going to take 30 minus X. Because I have a total of 30 liters, I'm going to subtract off what was used for the 10%. Okay? So now my equation becomes, well, I have 10%, change that to a decimal. I do that by moving my decimal point 2 places. So I have 0.10 times X plus 0.30 times 30 minus X. And again, it was just a poor choice of numbers. This 30 and this 30 have nothing to do with each other, which then gives me my total of the 30 times the 0.25. So 0.25 times 30 for my number of liters for the final solution. Okay, and this concept right here is going to be used a lot, and that's the one that I would put a star by, not just this one, but paying attention to this. We're going to do that a couple more times even today, so pay attention to that. And also, maybe when else should we pay attention to it? Yeah. Take the hint. Okay, so we're going to solve this equation. So we have 0.10x plus, now we're going to pull out our calculators. And we get 9 minus 0.3x is equal to 0.25 times 30. We get 7.5. Now I want to stop for a second here, because one of the things that we used to teach, again, before we all had calculators, is that we would get rid of the decimal. Okay, so see how I have a 0.10 and I have a 0.3 and I have a 0.5. So what we could do is, just like we cleared fractions, we can actually clear decimals. Now it is not necessary, and so that's the reason I don't really teach it as much anymore, but you can clear the decimals by multiplying by 10 or 100 or 1000. And what you do is you decide, what's my largest decimal point? My largest one is, I have 2 decimal points here, so I can multiply every single term by 100. Now you do not have to do this, but I just want to show you this is an option. If I multiply by 100, everything moves 2 decimal places, so I have 10x. But everything has to move, just like we multiply every single term. I would take 9 times 100, so I'd get 900. Minus this, I'm going to move it 2 decimal places, so 30x is equal to 2 decimal places, 750. Okay, so this was really helpful when we didn't all have calculators. It's not as necessary now. Okay, so you can go back to the original equation if you want to. Since I did this, I'm going to just go from here. Combining like terms, I get a negative 20x plus 900 is equal to 750. And you're going, oh no, I have a negative variable, but watch what happens. It works itself out. Okay, you just sometimes have to be patient and trust the system. Now, of course, we're going to divide by a negative 20. And we get x is equal to 7.5. Okay, but we have to answer the question. How many liters of both the 10% and the 30% should she mix together? Well, we said up here that 10% is x, so we need 7.5 liters of the 10%. And now I'm going to take 30 minus 7.5, and we get 22.5 liters of the 30%. Okay? Okay, so now we're going to go and do another one of these. If you have room and you want to write another one down, that is great. If you're like, nope, I'm good. But I am going to do one more. And this one is not in your book, but it's, again, just a solutions problem. And these tend to show up, especially in Algebra 2 and pre-calculus. So it's better to have seen two of them. A lab technician needs 25 liters of a 13% solution. So this is going to be our final solution for a certain experiment. She only has a solution of 10% and 30%. Okay, man, they really like the 10 and the 30%. So how many liters of the 10% and the 30%? So it does not matter which one you choose to be x and which one is the other one. Okay, so I'm going to say x is going to be the 10% again. Why? Because it's the first one I read. That's how much it really doesn't matter. 10%. So I need to say liters of 10 liters of 10%. Okay? And now what is my total solution? Okay? That's how many liters I need of the 30%. But I'm taking the total number of liters and subtracting off what I've already used, which is x. Okay? So what I'm doing is I'm taking a 10% once again, plus a 30% is going to give me my total of a 15%. Okay? So we want to know how much of each. We are not actually adding 10% and 30% to get at 15%. We're talking about the liters for each of these. Because you always want to know is, how do I find out what my variable is? Go back to what they're asking. So now I'm going to change these to decimals and plug in what my liters are, which is 25 minus x and x. So in place of the 10%, 0.10, change it to a decimal point, that's x. Plus 0.30 times 25 minus x is equal to my total of 25 times 15. So 0.15 times 25. Okay, and I'm going to pause now and have you solve that equation. You can multiply through right here and get rid of all the decimals. You can do it later. You can just leave all the decimals. I'll let you choose. Now I came up with x being 18.75. Okay, so if you did not do that, you might want to go back and check your work. And if I've made a mistake, feel free to email me and ask me questions. So that's what my 10% solution is. That's 18.75 liters of 10%. Then I'm going to plug it in here. So I have 25 minus 18.75 is equal to 6.25 liters of the 30%. And this is my answer. Okay, but it just gives you one more example of a liter, of a solution problem. So this one is not in your workbook, but it showed such great information over here in this box that I wanted to make sure that we went through all this information. It will be helpful on the problem that is in your workbook. So you're going to be writing this information in the left-hand column of your workbook. Okay, 4 friends use an online code to get discounts on concert tickets. They spent $312 for the 4 tickets. What was the price of one ticket without the discount? The other reason we need to see this is because it tells us the discount over here, and it says that the discount is $15. That's the total discount. Okay, so what we're going to be working with here is we're going to look at, okay, we want to find out what was the price of one ticket without the discount. Okay, So we want to find out the X is going to be the price. Now look what I'm doing. Price of one ticket. I'm just taking what they're asking for. Price of one ticket without, that is short for without, W/O in notes, without discount. Okay, so that's the price of the one ticket without the discount. So what's the price with the discount? So price with discount would be X minus 15. Okay, that's the price with the discount. And it's really helpful if you write that down because then it's going to make more sense. Now, we bought 4 tickets. Okay, so 4 tickets. Okay, and that's going to be equal to what the price would have been if we had bought it without. So we're going to pay for 4 tickets. I'm sorry, not without. We have to know this is what their total was. So 4 tickets with discount. Okay, and what is that going to be equal to? They said that they spent $312. So with the discount, we're going to take 4 tickets times with the discount, which is this X minus 15. So you're like, well, why did I have to write this down? Because you have to be able to symbolize what's really happening here. Okay? And so this is what our equation would look like. Let's go and solve that now, please. So what they wanted to know, what was the price before the discount? What was the price had I paid full price? What would the price have been for each ticket? So it would have been $63 without the discount. So they saved money for 4 people in order to do that. Okay, let's go to the one in your workbook now, but we had to see what they were talking about, and it's just helpful if we see right here how we can symbolize that. Okay, so now here's the example that's in your workbook. We have these same 4 friends who are buying tickets for 2 shows on consecutive nights. Okay, now this consecutive is not going to have anything to do with consecutive integers. It's just saying they bought tickets for Friday night and for Saturday night. That's all it means. They use a coupon for $5 off each ticket. They pay a total of $416 for 8 tickets. Okay, so let's go and symbolize this and look at what is happening. So we know that they want to find the original price. So X, whatever they're asking for, that's pretty much what you're always going to say that's what your X is going to be equal to. So X is the original price. But what is the price if we have the discount? Well, I take the original price and I subtract off what each ticket would be. So I'm going to subtract off 5. Okay, now we have 8 tickets because they went for 2 shows. So we're going to have 8 tickets with the discount is going to be equal to our total, which is 416. This a lot of students do not want to write down, but they need to, because otherwise people just take 8 times X. That's the mistake that is made. But you need to realize our total here is because we had a discount. So we're going to take 8 times X minus 5 is equal to 416. Now we're going to solve this. Go. So we found out that the original ticket price is $57. Whoops. Okay. It's 57. If you got a different number, again, go back through your work, compare it to my work, and see if you can figure out where that mistake is. So each ticket is $57 per ticket before discount. Okay, good. This problem is right in your workbook, and we're going to do one here, and then we'll also do one when we finish up this lesson. So this one is one that we're going to have to totally pick apart. We're going to have to look at some other things that go along with it. And it's probably one of those that if you've ever seen people tell a joke about word problems in math, it looks something like this. It seems like it's difficult, but stay with me, we've got this. LaTanya leaves the house at 12:30 and bikes at 12 miles per hour to Marta's house. She stays at Marta's house for 90 minutes. Both girls walk back to LaTanya's house along the same route. Okay, So that's going to be one of our important concepts along the same route. At 2.5 miles per hour, they arrive at Latania's house at 3:30. How far is Marta's house from Latania's house? Okay, so let's start picking it apart. She leaves at 12:30, arrives at 3 hours. So the total trip is 3 hours. Yes? Okay, so we need to know that. Now, we also need to realize that first she rides her bike, then she is at the house for 90 minutes, and then they walk home along the same route, and the total trip, okay, is 3 hours. Now, the reason this is important is because everything has to be in hours. Okay, so it's going to be in time. Okay, and the other thing is we want to know how far is Marta's house. What is the distance from Marta's house to Latania's house? Distance. Okay, so on this one, what's going to happen is that we have to make everything time, even though we're talking about distance. Well, another thing you need to understand is when we're talking about time, there is a formula that distance is equal to rate times time. Okay, distance is equal to rate times time. Now, that is true, and since we have to have everything in time, we're going to get time by itself. So we're going to take and divide both sides by the rate. And when I divide by the rate, I get that distance divided by rate is equal to time. So that's how I'm going to get everything in time. Okay, so that's an important concept. This is in 12 miles per hour. And this is in hours, so we want to use hours. That is important. So what we're going to use is for the bike, we took the distance divided by the rate. How long did it take her to bike? 12. How long she was at the house? So she was there for 90 minutes, but we have to have everything in hours. So 90 minutes, okay, how much is that in hours? Well, that one we know is 1.5 hours. But what we would do is we would take 90 divided by 60 because we're converting minutes into hours. Okay, so 90 divided by 60 is going to be 1.5 hours. Okay, and then they walk for 2.5. But remember, we need to have that. That's a rate. We don't know the distance, so we divide it by 2.5, and that's going to give our total of 3. Okay, there was a lot to pick apart there. Pause for a second and see if you got all that written. So hopefully you got that all written down, and I wish I could say, are there any questions right now? But I won't be able to hear them. I'm sure that there are on the other end. Now, what we're going to do here is that we're going to we have fractions. We don't want fractions. We're going to multiply through by a common denominator. And you remember I said in class that in math, to have a mixed number is really a pain, so we're just going to take care of that right now. Okay, and had we just left it as a mixed number, so I could have simplified up here where I had 90 over 60, I could have just reduced that down to be 3/2. Now we're going to get a common denominator. This one we could have just multiplied 12 times 2 times 2.5. The other thing we can do is we know that anything that 12 works for, 2 works for. So we could just take 2.5 times 12 if we want to. I'm just going to multiply them all together, and I'm going to use a common denominator of 60 and multiply all of them by 60. Don't forget to multiply over here also. Okay, so when we multiply here, we're going to see that 12 goes into 60 5 times. I'm just taking 60 divided by 12, and so I get 5D. 2 goes into 60, that's a 60. 30 times, so 3 times 30 is 90. 2.5 goes into 60. That's not one we just know off the top of our head, but it shows that all we're doing is taking 60 divided by 2.5, and we get 24D is equal to 180. And now we're going to solve that equation. Okay, go. So we came up with a decimal that continues on forever and ever. We don't even see where the pattern is. We know that it does repeat at some point because we have a fraction right here. Okay, so we know it's a rational number because we can write it as a fraction. Now, this is an example of we don't want to give the answer as a mixed number. If it were just an equation, yes. But we are talking about a real world problem. How far is Marta's house? So we're going to just approximate. We're going to say it's about 3.1 miles. Okay? Now, let me tell you a little secret. The good news is there will not be one like this on the test. So you're going, why'd you make us go through it? Because your brain needs to see this and it is beneficial. Now there's some other stuff to go through, and what I'm going to do on the next couple pages, I'm just going to quickly go through the answers because this video is getting long and I just want to let you know the information, but I'm not going to drag you through all of it. Okay? So let's go to your workbook and go through all that pages, and you can just write down what I have and I'll go through it quickly. So if you have equations with fractions, it's helpful to multiply through so that you can clear the fractions and have an easier equation. So you can clear the fractions to have an easier equation to solve. Okay, and again, it does not have to be the lowest, it just has to be a common denominator, especially since we all have calculators. So what this problem is asking you to do is to convert 5 miles per hour, and we were doing conversions with time, and so I just want to show you really quick. This is called unit analysis. I start off with 5 miles per hour, and I'm going to write it 5 miles per hour, and that means 1 hour. I want to end up with kilometers per hour. So that's going to be your big clue. And always keep it the same. So see how I have hours here, I have miles here, I have hours here. So I need to get rid of miles. So those have to be across from each other. And I need hours and kilometers up here. So I'm going to have that it is 1 mile to 1.6 kilometers. And then what's going to happen is we can cancel out our miles, and we have that we're going to end up with 5 times 1.6 kilometers per hour. Because see, we have kilometers, that's not hours. Kilometers. So then we have kilometers and hours left. So you're going to multiply, and that was her mistake. My program is not wanting to work, so I'm just going to give you the answers to 5, 6, 7, and 8. And then number 10, I'm just showing you what's happening again. And he walks at 2 miles, so this is going to be D over 2. D over 2. Plus, how long does he watch the movie? He does that for 2 hours and 15 minutes. So 2 hours, and then 1/4 of an hour, because 15 minutes equals 1/4 of an hour. Plus, and then he's going to ride back home, and that's at a rate of 40 miles per hour. And that's going to be my total time, which was 3.5 hours. Okay, so in order to solve this, you're going to have D over 2. Change this to an improper fraction. 2 times 4 is 8, plus 1 is 9, plus D over 40 is equal. Change this to an improper fraction. That's 3 1/2. So that's 6, 7, and 7/2. You would then multiply through by a common denominator. A nice common denominator right here is 40. You would then have the 2's would cancel, and I would get 20D plus 90 plus D is equal to 140. Solve that equation. After you solve the equation, you're going to get D is approximately equal to, well, it's equal to 50 over 21, which is approximately equal to 2.38 miles. Okay, good. If you have questions, you know where to find us. Sorry it was such a long video. Make sure you do the homework. And remember, it's a 2-day, so the assignment might have been posted on the day before. Thank you very much.